Hello, class. Okay, so we are in section 3.7. Okay, we are not doing section 3.6. And this is the last section in chapter 3, okay, and it is about rational functions. Okay, so we kind of know a little bit about rational functions. Okay, so it's r of x, and a rational function is just a function that is a polynomial over another polynomial. Okay. And so we know one of them, right? One of them that we know is, recall, f of x equals 1 over x, because technically this is a polynomial, okay? And we know that this looks like this, right? So if I draw it again, it kind of looks like this, okay? And we're going to talk a lot more about this function today. So when I introduced it, I always drew these lines, right? So this vertical line, which we called a vertical asymptote, okay, at x equals 0. And I also drew another horizontal line right here, and we called this one a horizontal asymptote at y equals 0, okay? And so y equals 0, x equals 0. All right, and so the vertical asymptote, if you notice, is technically where we can't plug in, right? Because the domain of this is x can't equal 0, right? And that's where the vertical asymptote is. And that's kind of what rational functions do, okay? And so I'm going to introduce this notation about what kind of happens around here in the asymptote part. Okay, so as x goes to, I'm going to use an arrow to kind of mean goes to or tends to, okay, 0, but like as x goes to 0, right? Like what direction? Am I coming from here or am I coming from here? Okay, so to tell you what direction I'm coming from, I'm going to put a plus or a minus, okay? And that means the right, okay, or the positive direction. So this piece of math says as x, right, as your x coordinate, right, as you get closer and closer to 0 from the right, okay, what's happening? Well, what happens is that basically y, okay, or f of x, whatever you want. So f of x comma y goes to positive infinity, or it goes up, right? And then we have the other version of the sentence. So as x goes to 0 from the left, okay, or the negative direction, right? Okay, so I'm on the left side now. What happens is I get closer and closer to 0. F of x slash y goes to negative infinity, or like down, right? It keeps going down forever. And you see that they're different, right? Like the signs matter, right? This goes down to negative infinity. This goes up to positive infinity. Okay, and that's kind of one of the big focuses of this section. Okay, so let's do an example of a function that we should be able to graph, okay? So here's one example. So 1 over x minus 3, x plus 2. Okay, so automatically, since it's already factored for you, okay, you should know that the domain is x can't be 3 or negative 2, right? Those are the two parts of my domain that are missing. So automatically, you should know that you have a vertical asymptote. Okay, you have multiple. They are at x equals 3 and negative 2, because that's where the function blows up, okay? Now, I'll show you this later in the section, but basically, if it looks like this with a 1 on top, your horizontal asymptote is just automatically going to be the x-axis, or y equals 0. Okay, so the horizontal asymptote here, y equals 0. Okay, so then we learn to draw this thing. Okay, so I'm going to get my grid. All right, and I'm going to go to -2 and 3. Okay, and then I'm going to draw my asymptote. So here's x equals 3. Here's x equals -2. And then the horizontal asymptote, y equals 0. Okay, so now I need to check where am I going to draw this, because I have options, right? I could be here, I could be here, I could be here, I could be here, I could do this thing, right? Like I don't really know what's happening in between my asymptotes. Okay, so what you do is you kind of check like end behavior. Okay, so I'm just gonna plug in some numbers. Okay, so like this is the number 3, right? I'm gonna plug in 4 just to see what happens. So I'm gonna check x equals 4. Okay, and if I plug in 4, 4 plus 2, I get 1 times 6, so I get 1/6. Okay, so that means I'm here, right? Which tells me all I need to know, because that means I'm on the top part of this asymptote, and it should do this. So if it was negative, I would draw this one. But since it's positive, I just drew the top one, okay? And then I'm going to do the same thing over here. So I'm going to plug in -3 or -4. It doesn't matter really. But if I plug in -3, I'm going to get -6 times -1, which is a positive number again. So that means I'm up here again. Okay? All right. And now I need to check the middle. So what's happening with the middle? So actually, if you notice, x equals 0 is fine, right? I can plug in x equals 0. So I might as well plug in x equals 0 just to find the y-intercept, right? So I'm going to plug in x equals 0 to get the y-intercept. Usually we like that. So if I plug in 0, I get -1/6, right? -3, 2, -1/6, which means the y-intercept is here, which tells me I'm on the bottom half, because, right, we normally don't cross the asymptotes, so you can just guess it's this thing, okay? All right, now, I'm just a little afraid, actually. No, okay, no, we're fine. Yes, we're good. So yeah, this is the picture. Oh, wait, let me draw it in red, so it at least looks the same. There, this is my function, all right, these 3 lines. And might as well actually, so I'm gonna crack open Desmos, all right? What is it, x minus 3? Oh, wait, no, I did x plus 3. X minus 2. Is this what I drew? Yeah. And as we see, I'm good, right? I can even do the, just kidding. X equals -3, -3. Right there are the 2 vertical asymptotes, and y equals 0, horizontal asymptotes. And we see everything is, going in its place, how it's supposed to be. Okay. So yeah, this section is a little complicated. Like, I understand that this is hard. So actually, in addition to these notes and the regular notes, if you go into, let me back out here. If you go into our files for class, right? If you go into just the notes folder, yeah, the notes folder, you see that there's just these random 2 Obviously, this one is section 12.6, which that's the only thing we're learning in chapter 12, so not a thing. But if you go here, you can see I have this thing called rational functions, which is specifically for right now, this class. Okay, so I made this like little thing on how to graph rational functions. Okay, so if you want to look at more examples and where I like talk about it, feel free to do it here. I have two pretty good examples with, you know, a nice graph. All right. But yeah, let's get back to the notes. Okay, so let's do this example now. Okay. Actually, okay, let me just explain. Let's before we do more examples, let's do how do I figure out the horizontal asymptotes? Okay. So the asymptotes of rational functions. So if we have, right, rational function, and we know a rational function is just a polynomial over a polynomial. So it's technically this giant thing that I'm about to write down. Okay, and then b bn minus 1 plus dot 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 plus b1x plus b0. Okay, so here's a rational function. All right, the first rule is how do you figure out the vertical asymptote? The vertical asymptote is the line x equals c, where c is a 0 of the bottom polynomial. Okay, so the vertical asymptotes are just when the bottom is 0. Okay, which is also the parts where the domain is not in the domain. Number 2, and this is why I'm mostly talking about this, all right, is how do we figure out horizontal asymptote? Okay, well, there's actually 3 rules to this. Okay, so it's a little complicated. But if I should have done it like, okay, so the powers on the bottom polynomial, I'm going to use m minus 1. Okay, so if n is less than m, or the polynomial on the bottom has a bigger degree than the polynomial on top. Okay, so if the bottom has a bigger power than the top, okay, then the horizontal asymptote is y equals 0. Okay, and this is why up here I told you the horizontal asymptote is 0, because the bottom has power 2, right? That's a quadratic polynomial on the bottom. But the top is just a number, right? It has power 0. So that was an example of when the bottom is bigger than the top. So you're going to get y equals 0. Okay. Now, if they're equal, so if m equals n, if they have the same power, then the horizontal asymptote is y equals an over bn, or also known as the ratio of the lead coefficients. All right, and then we have the last case. So if the top has a bigger power than the bottom, you don't have a horizontal asymptote. Okay. Okay. In fact, you have something that we're going to talk about later in the section. Okay. Also, apparently, we are doomed. We're doomed. All right. Also, we're going to have something called a skew asymptote. All right. Okay, but so now that we know this, let's do this example. Okay, we want to graph 3x plus 5 over x plus 2. All right. Okay. So the vertical asymptote, hopefully we can all see, right? It's x equals -2. All right. The horizontal asymptote, right? These have the same power. So the horizontal asymptote is y equals 3 divided by 1, or 3. Okay, because right, it's 1 here. Okay. And then okay, we graph. Excuse me. So here is -2. That's where I'm going to draw the vertical asymptote. The horizontal asymptote is 3, so I have to go up. And it's actually here. Okay, so now, right, I have two options, right? Am I going to be down here or up here? Down here or up here? Okay. So I need to plug in some numbers, right? So since 0 is fine, right, I want to plug in 0. So if I plug in x equals 0, I get y-intercept of 5 over 2, which that's like a positive number. It's a tiny positive number though, 5 over 2. Oh wait, no, 5 over 2, that's like 2.5. So it's actually here. But either way, it's less than 3, so I know I'm under. Okay. And now I need to plug in something, to the left to see where I'm going to be. So I'm going to plug in I'm going to plug in x equals -3. Okay, so then I'm going to get -9 plus 5 over -3 plus 2, which that's going to be -4, -1, which is 4, which we know is going to be like right here. So I get up here. Okay, and this is pretty much how this goes. All right, it's kind of like making a sign chart in a weird way. But here's this graph. All right, now I'm actually going to show you some extremely fancy trick right now. Okay, because in fact, okay, very specifically with this one, you could have done this. Okay, if you have a line over a line specifically, okay, then what you actually can do, if you feel like it, is you can synthetic, well, no, you can long, we can long or synthetic divide, it doesn't matter. I'm going to long divide. Okay, so we see that we get this. Okay, so remainder, right, this is the remainder. So we know 3x plus 5 divided by x plus 2 is equal to 3 minus 1 over x plus 2. All right, and actually this now you should know how to graph from chapter 2. Okay, because this is a shift left 2, that's a reflection, and this is a shift up 3. Okay, and if you notice, that is correct, right? I took the original, right? The original would be the reciprocal function we all memorized, and I went over 2, up 3, and then, right, I flipped it, because normally this one's on the bottom and that one's on top, but then I flipped it. Okay, so this is an extremely fancy trick if anyone wants to try this. Let's do another one. Okay, just for, extra exercise. So here I have another line, x plus 2 over x minus 3. Okay, we have vertical asymptote 3. We have horizontal asymptote y equals, right? It's 1 over 1, so the horizontal asymptote is 1. Obviously, we can stare at it. We can see that it has a 0 at -2, right? When I plug in -2, it's 0. And that's pretty much all I need to know, okay? Because, oh, did it work? Yes, it did. Okay, so if I have the vertical asymptote at 3, horizontal asymptote at 1, okay, and I know I have a 0 at -2, right? So -2, I have a 0, so that automatically means I have something like this happening. That's a pretty bad drawing, but you get the idea. That means that this one should be on the opposite side. I don't know if you guys have noticed that, but they're almost always on the opposite side. Okay. But also if you want it to long divide, it becomes this after long division. Okay. So you see you have a shift right 3, a shift up 1, and a stretch by 5. Okay. So you get this drawing, which you should always label your asymptotes, right? Label the asymptotes. Awesome. Okay. So now let's get a little more complicated than just lines over lines again. Okay, let's go back to like these kind of examples, okay? So here, okay, I'm gonna have a quadratic over a quadratic, okay? All right, so step 1 is you probably want to factor everything, okay? And hopefully it does factor. So if you factor the top, right, stare at it, you're gonna get 3x plus 1 and x minus 1. If you factor the bottom, you're gonna get 2x minus 1 and x plus 2. We see nothing cancels, okay? But so this is what we're gonna deal with, okay? So now we can see that we have vertical asymptotes at x equals 1/2 and -2. We have a horizontal asymptote, right? The powers are equal. So this means it's 3 over 2 is going to be the horizontal asymptote. Okay, 3 over 2. And then we know zeros, okay? So we can see the zeros of the function easily, right? The zeros are -1/3 and 1, okay? And that's kind of all I need, okay? So I'm going to draw, okay? Let's get the horizontal asymptotes here. So I'm going to draw this one. This is at 1/2. 1/2. Okay, so x equals 1/2. And then -2. So 1, 2. X equals -2. Horizontal asymptote at 3 over 2, which is, I'm just going to draw that there. Y equals 3 over 2. Okay, now I kind of need to guess what happens. Well, I know at, right, x equals 1, I am 0. So automatically I know this one. Okay, x equals -1/3 is here. Okay, but this is actually a very important example. Okay, of it's actually not gonna be this. Okay. And I'll talk about that later. But first I'm gonna get this side. Okay, so I'm gonna check like x equals -3. What happens when I plug in -3? So here, I'm gonna do kind of like the sign chart thing I did, where I'm not really gonna care what numbers I get. I just want to check, is it gonna be positive or negative? Actually, no, I think I actually have to care though, because this is 1. This is 3/2. So I'm actually gonna plug in. Just kidding, I lied. -3. Okay, so -3, that's gonna get me -8 here. That's gonna get me -4 here. I'm gonna get -7 here and a -1. All right, so that's going to be 32/7, which is like 4-ish. Okay, which means I'm up here. All right. Okay. Now for the middle part, okay, I'm going to actually do like the end behavior thing. All right. So what I mean is I'm gonna need to figure out what's happening to x as I get closer to -2. Okay. From the right. Because I already know what's happening from the left, right? I'm going this way. I need to know, am I gonna be up here? Do this thing. Okay. Am I gonna be down here, which is what we're all guessing because I know this black dot, right? So when I plug in 2 from the right, okay, so if you want to do this like numerically, you just plug in something really close. Like, so I would plug in like -1.99. Okay, that's kind of what I mean, or like -1.999, right? You want to get really, really close to -2. But if you want to do this without a calculator, okay, you just think about what sign you're gonna get, okay? So if I plug in -2 from the right, okay, then this number is definitely negative. This number also negative, because I'm gonna get something like -5, okay? This number also negative, because right, negative minus a number is negative. Okay, this is the interesting one, right? Because that's the one that's 0, right? If I actually plug in -2. But if I plug in like -1.999, right? That's actually smaller than 2, right? So this will be positive. So that means I have 3 negatives and a positive. So this means y goes to -infinity. And my arrow should be here. Okay. Now, I should do the same thing for the other asymptote. Okay, so what happens to x as it goes to 1/2? Okay, from the left, right? Because I already know it's going down here, right? I need to know, am I going to be up here or down here? Okay, and so I do the same sign chart thing. Okay, so if I'm plugging in something like, so 1/2 is 0.5, right? So I want to plug in something like 0.49999, right? Something barely smaller than 1/2. Well, this is going to be negative. This is positive. This is positive. What about this one, right? So if I plug in something smaller than 1/2, okay, then this right here, right, like a third, let me plug in a third. So 2/3 minus 1, we know that's negative. So this is negative. So then the negatives cancel and you actually get a positive, which means this blows up to positive infinity. So you get this end behavior, okay? And it's actually, this is doing a really weird thing. This is crossing the horizontal asymptote, which is allowed sometimes. Okay. So just wanted to show you, be careful that it's not always going to be a U-shape thing in the middle here. Okay. It can do weird things. And so let me, let's look at this on Desmos. All right. So here I'm going to get 3x plus 1, x minus 1. 2x minus 1 and x plus 2. And we see that, yeah, okay, I'm basically right. So x equals -2. There's that vertical asymptote, right? X equals 1/2. There's the other vertical asymptote. And y equals 3 divided by 2. And we see there's the horizontal asymptote. And we see that this thing is doing, this cubic looking thingy on the inside. All right. So yeah, you need to kind of be good with this end behavior kind of thing. All right. Where you plug in a number that's just like a teeny bit bigger or a tiny bit smaller. All right. Okay. Now let's move on. Okay. This is going to be the last example of this kind of thing. So let's do 5x plus 21 divided by x squared plus 10x plus 25. Okay. So automatically, well, not automatically, I guess. You should factor. Okay, so the top is what it is. The bottom is actually s plus 5, x plus 5, right? It's a formula. It's the square of the binomial. So this means we actually have vertical asymptote x equals -5, like twice, sort of, right? The horizontal asymptote is y equals 0 because the denominator has a bigger degree, right? So we actually don't have a lot of info, right? I know I have horizontal asymptote, y equals 0. Vertical asymptote at -5. But I don't really know much, right? So I'm going to do the end behavior thing, right? So what happens when I plug in a number a little bit smaller than -5? Okay. So if I do a little bit smaller than -5, this is going to be negative and that one's going to be negative. The top, right? So I could do like -6 even, right? The top is going to be negative. So all three of these are negative. So that means I should be pointing down. Okay. And so that means that should happen. Okay. Now though, let's do the same. So what happens when I go from the right? Well, that means these are positive, right? Because it's a little bit less than -5 or bigger. And then the top is actually still negative though, right? Because if I plug in like -4.5, we can see that it's bigger than 21. So the top is still negative. So actually I'm pointing down both of these. Okay. And then just to show you something weird, like let's plug in x equals 0 to find the y-intercept, right? That's 21 over 25. Okay, so that's like up here, which is weird, right? Because I'm down here, but I have to go up here. So I actually do cross the horizontal asymptote and then go back down to it, okay? And I get this, weird looking graph, okay? Which I can, again, let's plug this one into Desmos. And we can see, so fraction. 5x plus 21 divided by x plus 5, x plus 5. And we see exactly what happens, right? So we have the vertical asymptote at x equals 5. And we see that, yeah, they both should be 2 down arrows, right? And then we see, though, that, right, we go up, we cross the horizontal asymptote, and then magically just start going back down. Okay? So you need to, again, the horizontal asymptote is more like a suggestion. All right? Sometimes it gets crossed. Okay? The vertical asymptote will never be crossed, though. That one is a rule. Okay, not a suggestion. All right. So last part in this section, okay, which is not a big deal. I'm just gonna do like one example, because it's complicated. Okay, is I'm gonna do the last case that I haven't done, right, which is what I called a slant asymptote. All right, so a slant asymptote happens when the power on the top, right, the degree of the top is bigger than the degree of the bottom. Okay, so what happens is what you should do, because since the top's degree is bigger than the one on the bottom, that means that actually that is unsimplified. Okay, and you should be able to simplify it to get something like this, where you get another polynomial that's just out there without a fraction. Okay, and this right here, this extra polynomial, that is the slant asymptote. All right, so here's an example. Okay, so if I have x squared plus 2x over x minus 1, right, then I have to get it to look like this. But how I do that is I divide. Okay, so I'm going to synthetic divide this time instead of long divide. Okay, so 1 falls down, 1, that's 3, that's 3, that's 3. Okay, remainder. Okay, so we know that this equals, right, x plus 3, remainder 3, so that's plus 3 over x minus 1. And now you can graph this, okay? So what do I mean is, so we can see a vertical asymptote right away, right? So we know the vertical asymptote is 1. What we didn't know is this is the slant asymptote. So you graph the slant asymptote. So I'm going to go to 3. And it's going to be this line. And now you also see why we call it a slant asymptote. Okay? Because it's like literally slanted. All right. Okay, that's fine. All right, and now you can just check, right? Like where am I going to be on this graph? Okay? You probably don't want to pick end behavior this time. I mean, you could. So I'm going to plug in like a little bit 1 from the right as x goes one from the right. So if we plug into this thing, right, we're going to get that the top is positive and the bottom is positive. Right, so we're going to be up here. Okay. And then now I'm just going to plug in like 0 because might as well find the y-intercept. And actually I get 0, right? So if I plug in 0 into my function, okay, f of 0 is actually 0. So I should get something like this. Okay. And let's plug this one into Desmos and wrap up this section. So this was fraction x squared plus 2x divided by x minus 1. And we see it looks like what I said, right? It's this weird kind of curved one. And we see the 1. Vertical asymptote, right? That's working fine. And then actually, right, x plus 3, we see that the slant asymptote, right? That's what's happening there. Okay. So not horizontal, it's like slanted, right? And we get this like V thing. All right. But that's the slant asymptote case. Really, it's not that much harder. You just have to synthetic or long divide at the start to get the slant part. All right. So that's it for section 3.5. If you want more examples, again, I recommend you look at that file I uploaded on Canvas. But that's it for 3.7, which is actually, that's it for chapter 3. All right. See you guys next class.